In this stop, we will share the geology, formation, and some fun facts of the unconformity with you guys. Let's begin with the geology of Siccar Point first. As we mentioned, this important site is famous for its unconformity with a large age gap which inspired James Hutton on his understanding and theory of the Earth process and cycles. The unconformity divided two big sets of rocks, presented with their deep angle different. Below the separation line, it was formed by sandstone and mudstone, while the above part is formed by red sandstone and basal conglomerate. Starting with the set of sandstone and mudstone, they were formed approximately 435 million years ago in the Silurian period. During that time, it was flat-laying layers under the deep water environment. The gentle current brought very fine-grained mud into the area and formed the mudstone layer. The specimen of the sandstone in this part of the site is great rock, which consists of a mixture of rock fragments in a fine matrix of clay. This rock type has a clastic texture with a hardness of around 6 to 7, gray to black in color. It is common to find quartz, lithic, pyroxene, muscovite, biotite, and both orthoclase and plagioclase feldspar in the gray rock. Because it was found unsorted, therefore we can know that it was formed from fast-moving torrents sweeping down the slope in that area. This process was done every period of time, hence it formed the layering in the rock. Nowadays, we can observe that the layer is vertically dipped because it has experienced folding and other tectonic movement before the upper conformity layers form. Moving on to the upper part of the unconformity, this set of rocks contains Devonian red sandstone and basal conglomerate, where the red sandstone is located on top of the conglomerate. Basal conglomerates are usually found above an unconformity surface and at the base of the sedimentary sequence, which acts like a transitional layer between the two. Many angular rock fragments of different sizes can be easily found in the conglomerate. These fragments are a result of erosion on the gray rock, which spent 65 million years on the surface before the formation of the conglomerate. One interesting thing is that the pointing direction of the fragments also shows the flow direction. In this case, the flow is from the northeast. On top of it is the red sandstone. This kind of rock is common around Scotland. In order to form the red sandstone, interchanging of wet and dry seasons where the sand and silt deposit on the river declined during wet seasons and blown by the wind during the dry seasons. One quick question, do you know why the sandstone has a red in color? 3, 2, 1. Okay, it is because of the iron content where it was oxidized, giving out a rusty color. So now, I think you would have more understanding on the types of rocks presented in this site. Now, I will pass to Jason to talk about some fun facts and the formation of this unconformity.
This is probably an end for our field trips, so I'd like to share some fun facts for the conclusion, and I will also tell the original story about Siccar Point, and we'll welcome Kyle for his final remarks. Alright, the first fun fact is that more than 1,000 years earlier, the ancient Britons built a small hill fort here to warn off invaders from the north, the Vikings actually. People at that time regard the military importance of this place, but no one had ever realized how Siccar Point illustrated the story of the hearse itself. Another fun fact is that, as mentioned before, after visiting Siccar Point, Hutton develops an idea that debunked the conventional biblical interpretation about the Earth's age. This evolutionary idea changes the course of science and influenced Darwin, who is a small student, on his natural selection theory he later developed. This theory will not exist without Hutton's observation at the Siccar Point. if the Earth only exists for supposedly 2,000 years, such theory will not exist. The final fun fact is that the Siccar point is the very first angular unconformity identified. Alright, let's move on to how Siccar point forms. Well, we will use the diagram shown on the screen and describe each step in details. So, there are two sets of rocks on Siccar point. There are the dark gray vertical rocks at the bottom and the younger horizontal red rocks at the top. They are separated by an unconformity, an ancient land surface consisting of eroded conglomerates representing a time gap in a normal geological sequence. 435 million years ago, greywack, a type of sandstone, and mudstone were deposited under the sea. Then, the sedimentary rocks underwent folding, faulting, and uplifting to the surface. These layers of sedimentary rocks had experienced mechanical weathering, such as waves and wind, and formed detritus until 370 million years ago. At that moment, red sandstone and basalt conglomerate were deposited at the top of greywacks. After that, the new entity of two sets of rocks underwent uplifting and tilting. They shaped like the current shape we are observing. While the seawater retreated and advanced, also wind blows for nearly, I would say, 200 million years. Erosion took place on Siccar Point's geology and gradually created today's landscape.
Thank you, Jason. This will be the end of our trip. Thank you for your participation. We hope you can remember the following things before you leave. Even the Siccar Point is a small geological site in Scotland, but it had made a huge impact on the estimation on the age of the Earth. Thanks to its unconformity with a 65 billion years gap. We would like to invite you to come visit the site in the real life after the COVID-19 issue, to enjoy the beautiful view here and as well as feeling how amazing the nature is. Once you get there, be careful of the grassy slope down the rock because it is steep and slippery, which can be very dangerous. Remember, safety first. Once again, thank you very much for joining us. Hope to see you in the next trip.